Engineering is a geotechnical engineer and specializes in all things geotechnical and frequently defends realtors and does presentations in court. And so they've asked him to come up here and talk about what you should be looking for. And I think he's going to give you some insight into, the legal process and what they're looking for. And he hails from Cal. Anybody here from Cal? I like Cal. It's the sister thing for UCLA. So anyway, I like you. Come on up here. This is Yoshii with 2 eyes, right?
That's right.
Okay.
You need to attach that. I need to attach that.
Yeah.
Can everybody hear me okay? Yeah. Do it up a little bit. Is that better? It works? Okay. Let me see if this is working. Excellent. Real quickly, I'd like to thank you guys all for having me here this morning. Again, my name is Yoshii. I'm a principal engineer at Nino & Moore, and we are a geotechnical environmental consulting firm. Just a little plug about my company so that my marketing staff is proud of me. We have offices throughout the Southwest United States. We kind of listed them here. San Diego, California, San Diego, Irvine, Rancho Cucamonga in Southern California, Oakland, and San Francisco in the Bay Area. And then also offices in Arizona, Nevada, Colorado, and Texas. Jim asked me to talk today a little bit about geotechnical engineering, somewhat with regards to the legal process, and also maybe to give you a little bit of understanding about what are really soils, what are soils, how do they behave, what are some of the issues that we see as engineers and you may see with real estate, especially residential family homes. First, just briefly, the construction process. I'm sure many of you are aware of this, and some of you might not. It usually starts with the kind of an owner, and then you have your kind of developer team, the builder, oftentimes for residential, maybe the same. The financial institution, of course, the regulatory agencies, the local building department, typically. Then you have your design team, typically the civil engineer, the geotechnical engineer, architect, maybe the landscape architect, anyone that's putting input to the design. And of course, then the contracting team, the people who are actually going to build it, and all the various subcontractors. Now, why is this important? Well, this is important because there's a huge interaction in what we do as engineers, as designers, with regards to what the owner wants, what the ultimate product is going to be, and then also how is it going to be constructed, what's it going to be built. That process, as you know, can take months and sometimes years on larger projects, and it's very important that we have communication all the way up, top down, all the way across to make sure we have a very effective project. So what is it that geotechnical engineering do? What do we do as consultants? Well, in a new construction job, we will look at, or an area, we are looking for different things. Geologic hazards, I'm going to talk a little bit about what those are, explain some of those. I'm sure some of you are very aware of some of the issues such as landslides, liquefaction, things like that. Oftentimes those sites require special design considerations. Of course, we design, or I shouldn't say design, but we give parameters for the foundations. Depending where you are, if you're going to be building out here in the marina, we're going to have different recommendations for the types of foundations you might use, opposed to being at the top of the hill in Palos Verdes. Very different conditions with regards to soils and what that building's going to be supported on. Drainage control, pavement design, quality control during site grading. We're not going to talk too much about that, but essentially that is during construction. We want to make sure that the things that we recommended in our report actually get implemented correctly. Some things oftentimes get implemented, whether or not they're done correctly oftentimes ends up being an issue during the litigation process later on. Finally, materials testing, inspection, forensic studies, of course, coming around the back end. If there are issues, if there are problems with buildings, we'll see a couple case histories with those. We'll then take a look at those buildings and take a look and try to kind of work backwards. What actually happened? What caused this distress, this cracking, this movement of this building, and how can we repair it? Some of the ways that we study this, we look at a bunch of different things. I'm not going to kind of go through each one of those for time considerations, but if you have a question on any of those later on, I'll be available to answer them. But I kind of want to show you some of the tools that we use. One is published maps. I don't know if have any of you guys seen a map, something like this, a picture of this, maybe in a report. Yeah, I see one gentleman, a couple people. This is what's called a geologic map, and essentially this is I don't know if you guys can read it. This is the Palos Verdes Reservoir. This is Western Avenue, just to give you an idea, PCH right here. So essentially what this map tells us is the types of materials that we might encounter depending on where we are. Again, these are going to be the geologic units, the types of soils or the type of bedrock material that we're likely going to encounter. Say if your property is right here, this is actually indicating this is a landslide area. So you want to be very careful. What does that mean? Well, that means that the land, sometime in history past, the land has actually moved. And so you want to be very careful if you happen to be in an area like that. So this is some stuff we usually start off. We take a look at where are we geologically? What do we know about the area? Some of the other potential hazards we're going to talk a little bit about today. The various how soils react, expansive soils, what is settlement? I mentioned landslides, faults, and earthquakes. As you know, in California, there's faults throughout Southern California, and we are in a high seismic area. All the buildings that are designed in California, whether they be residential all the way through high-rises, hospitals, and schools, are all designed for seismic criteria. And I'm not going to go too much into detail about that because it is somewhat a lot of numbers, and I don't know how interested you guys would be in that. Some of the other issues with soils and some of the properties, liquefaction, corrosivity. These are things that, as you're looking at a property, it's very difficult to assess just visually. But if we have the background information, we can also oftentimes tell you a lot about the property. I was mentioning faults. Here's just a fault map of Southern California. These are just some of the various faults that are known to exist. And when you're in one of these areas or close to one of these faults, depending on how close you are, it may require that you actually do a special study, a special fault study, just to identify the location of the fault. Now, most of the residential structures, unless it's new construction, typically don't fall under that. Schools and hospitals do. So work that we are doing, for example, for the Los Angeles Unified School District, if we ever get too close to fault, we actually have to make sure that any of the buildings that are built are set back a certain distance from any known faults. This is also another, as I mentioned, we're in a very highly seismic area. This is another map that we often refer to. It's a seismic hazard zone map. And what this map is showing, again, this is kind of the Torrance area, the Torrance kind of hills here, Palos Verdes is down here. But these green areas indicate liquefaction, areas that are potential or prone to liquefaction. And liquefaction is a phenomenon that happens in soils where under static conditions, under normal conditions, as we are standing today, the soils essentially, are solid. What happens during an earthquake, as the ground starts to shake and vibrate, those soils will actually turn into a liquid or have the properties of a liquid. Probably the best example of that in recent past is, I don't know if you guys ever remember, any of you guys remember the Loma Prieta earthquake up in San Francisco, the Bay Area, and some of the photos, the Marina District, while those buildings had collapsed or settled. That was liquefaction. Essentially what happened during that earthquake, all those soils in the marina, which, like I said, right now, under today's conditions, they would be able to hold up, they're solid. During the earthquake, they turned into a liquid. It had the properties of the liquid. Now, have you guys ever met, any of you guys know what the bearing capacity of water is? It's essentially zero. I don't know if you guys ever tried to walk on water, just step off a pool. Yeah, bearing capacity. There is no bearing capacity. Water has no ability to hold up anything. Okay. So what happens is you build things on it, they sink. Well, what happens if you build on liquefiable soils, when they're in a static condition, meaning no shaking, they're fine. But what happens when they start to shake and they turn into a liquid? Everything that on top of it will end up sinking. Now, there's some certain conditions. Question back?
What do you mean it'll turn into liquid? I mean, does it actually have anything to do with moisture or water?
Yes. One of the conditions in order to have liquefiable soils, there's really three conditions that exist. One, you have to have a very granular, sandy soil. I'm going to talk a little bit about the types of soils a little bit later in the presentation. The second element you have to have water. Okay, so the soils have to be saturated, or there has to be very high groundwater. That's why, obviously, in the marina areas, where the ocean, the water is very high. And the third thing you have to have is vibration, or some type of movement. And earthquakes create a tremendous amount of vibration. There are some very sensitive soils that will actually liquefy even under some construction loans. There's construction nearby. They can actually liquefy. So what happens, real basically, what happens to these really soils, these little individual granule particles, soils, you imagine a little sand soil. What happens as that area starts to shake, and if you took a glass of water and started shaking it, you could see the water actually moves. Okay.